M resultant. Okay, kemudian sigma A ni apa ni sebenarnya? Okay, ni tadi dia just sigma A, sigma for bending moment. Bending moment tadi dah campur apa mg over I tu. Okay. Five. Okay, ada soalan? Saya ambil soalan lah. Kalau kamu mana yang tak faham, saya jawab. Amin. Okey ke Amin?
Okey, doktor.
Okay, so ini 32 times M divide by pi D kuasa 3 tu, itu sebenarnya daripada yang asal tu yang apa tadi, MC over I tu kan. I tadi pi D kuasa 4 bagi 64 tu kan. Jadi dia dah simplify dengan dia punya apa tu, D tadi tu, D over 2. Okay, so that is, so equation 32 over kali M ni divide by pi D kuasa 3 ni is another apa formula lah, boleh pakai direct. Okay, for bending moment. Okay, for bending moment boleh pakai 32M divide by pi D kuasa 3. Okay, itu ialah asalnya yang MC ataupun MD square divide by 2. MD square divide by MCI divide by I. Okay, so 32M resultant. Okay, so 32M pi D kuasa 3. Then you have your sigma A. That is your sigma for bending stress, okay, at point A. And then at point A tu we have sigma or sigma axial, okay, axial loading. Okay, recall the formula P over A atau F over A. So the F is just your AX. Okay, AX is just 0.5 kilonewton. And then the area, cross-sectional area at point A for this one is for 4.9. This is for OA. Okay. OA punya area, cross-sectional area. Okay, so you can get that value 1.02 megapascal. Okay, this is stresses at point A. Okay, kemudian at point O, if you refer to point O just now, okay, for bending moment, you have your MOX, MOY dan MOZ. And if you look, okay, you have to find the M total or M resultant, MOX, MOY and MOZ. Okay, so take MOY value, MOY square plus MOZ square root, you get your M resultant, 195.26. Okay, and then that is for M resultant. And then what else? Okay, and then you have your axial loading. Okay, axial loading, you have force over A. Okay, F is your OX. OX is 0.5. A is 4.909 times 10 to the power of minus 7. Okay, and then if you look, okay, what is your MOX? Actually, MOX is, what is that? Fahmi.
Yes, doktor.
What is MOX actually.
MOX is, can I see the diagram, Doctor?
Okay, sorry. MOX saya tak nampak. Tak ada diagram ni boy. Okay, this is MOX. MOX. Okay. Kat belakang tu. MOX is
MOX. Tak clear, Doctor.
counterclockwise.
Oh, okay.
Kat belakang.
MOX ni kalau saya nampak dia reaction daripada MAX
That's
dan
right.
apa dia?
Betul. Okay.
Dan dia MAX ni pula adalah reaction daripada, saya rasa MAX ni adalah torsion yang terhasil daripada force. Dia adalah torsion daripada satu lagi batang A ke satu lagi batang A ke belah kanan tu.
Okay, good. Okay, that's right. Okay. So MOX, okay, so MOX is torsion. Yang tu yang my point lah sebenarnya, okay. So that's why from that point O tu, so you tengok betul-betul, okay, so you have your MOX, MOY, MOZ. For M resultant untuk bending, for that bending loading tu, so you just going to use MOY and MOZ to find the M total. For MOX, you're going to consider for torsion here, okay. For torsion, you have to use this shear stress punya formula. The shear stress formula is equal to 16 torsion tu MOX over pi d cube. So that is another loading at that point O and under torsion. So you have your axial, you have your bending moment and torsion dekat at that point O tu. So please, okay, so that is the point that you have to carefully understand. So at that point O, you should have these three types of loading. Okay, so you have your bending stress, you'll get the total, and then your axial stress, and then torsion is going to consider as shear stress. Okay, so to apply your sigma for bending, sigma OA, okay, 32 times the M resultant is 195. Okay, so and then pi over pi d cube. Okay, the d value, okay, be careful, the d value is 0.025. This is for part OA. Okay, part OA. Okay, the D, the shaft, diameter of the shaft is 0.025. Okay, for shaft OA. And then you get your sigma O2 137. Okay, for sigma axial you get your 1.02 megapascal. Then for shear stress due to the torsion, it's 61.12. Okay, so the three formulas, sigma bending, sigma axial, dan shear stress. Okay, so that is the approach you need to be familiar with. Okay, so remember, okay, this is one technique. Okay, so that is for A and B. Kemudian apa lagi? Itulah dulu sebelum kita masuk ke the next one. Okay guys, any question? M1, you are there, M1. Can you understand, M1? Amirul? Amirul ada? Amirul Shah?
Ya ke?
Okay tak?
Okey lah ke?
Okay, good. Boleh semua. Okay, bagus. Apa lagi pun masuk ni? Kamarul Zafran. Kamarul Zafran. Kamarul Zafran. Kamarul Zafran. Okay, so Hanani okay ke Hanani?
Okay.
Nisha? Are you okay, Nisha? Firdaus? Ada ke Firdaus? Kami tadi ya. Okay, so hopefully you are okay. Kemudian kita tengok latihan-latihan je. Exercise example so that you can understand. Okay, so tadi apa on stresses Okay, so these are the stresses. Okay, involve element stresses. Okay, kemudian more circle, nanti going to look lagi more circle ni. Okay, so please recall balik more circle punya apa ni, dia punya stress transformation. Okay, so remember the sign convention. Okay, for our class, okay, we are going to use the sign convention clockwise positive yeah, for shear stress. Okay, for the shear tau xy tu, tau xy clockwise positive, counterclockwise negative. Okay, so this is the equation dia. Okay. Okay, nanti kita tengok. Okay, so remember any discontinuity in the part, if you have the component, okay, any hole, any changes in the diameter, okay, it will create ataupun it will form the stress concentration. Okay, so stress concentration factor will be included, okay, in the analysis of the component soon. Okay, so if in the component, in the part kita tu, any irregularity, okay, and then okay, we need to include in our calculation, okay, the stress concentration. Okay, any discontinuity in the machine part alter the stress distribution in the neighborhood to discontinuity so that the elementary stress equation no longer describe the state stress. Okay, so what happen, it will change the stress distribution, and then we have to use some of this stress concentration factor. KT is the normal one, KTS is the shear. Okay, so a bit of modification. Okay, so these are the example. If we have the stress concentration, okay, we are going to apply the changes in the diameter. For example, okay, there are two parameters. One is R over D. R is the radius. D is the small diameter. So just refer to the figure, okay, and to the object image. Okay, find what is R, what is D, and then get the value. And then using the blue line, D over D, the capital D over the small d. So we need to find the two apa ni, section, okay, of that two parameters, and then we will get our KT value. Okay, so for example, if you have your R over D equal to 0.05, okay, so draw a line, a straight vertical line based on that R over D, okay, and then you have to check the blue line, D over D, the capital D over the small d. Okay, you are given for example 1.5, and you check in the blue line, there is no 1.5. So what happened is that you need to consider the in between the line 1.1 and the line equal to 2 tu. Okay, the equal or greater than 2. So in between the two lines, okay, and then get your KT value. So that is the approach. Okay, if you don't get your D over D exactly, so you need to assume the best possible location for that. Okay, D over D, capital D over D. So that is for stress concentration. Then this is what? Okay, this is another exercise. Okay, another example. Syed Hassan, saya tengok okay tak example ni? You have 40 mm diameter solid steel. Two pulley are keyed to the shaft where pulley B of diameter 100 mm and C. Considering bending and torsional stresses only, determine the location and magnitude of the greatest tensile, compressive and shear stress in the shaft. Okay, you have two pulley B and C. Okay, and then you need to determine the location and magnitude of the greatest tensile, compressive and shear stress in the shaft. Okay, kalau this type of question, then you can go using the apa tu, the 2D punya approach. Okay, so solution tengok sikit. Okay, you can use the approach. Okay, this is the solution. Okay, so you can tengok from XY plane and then XZ plane. Okay, so this you can use this approach. Okay, tengok boleh faham tak? Syed Hassan, okay tak? Ada soalan? Tanish ada dengar ke Tanish? Tanish ada problem ke? Mike?
No problem, doktor.
Okay, boleh faham?
Boleh, doktor.
Okay, good. Syahmi, ada ke Syahmi? Mana saya tak tanda kamu ni? Muaz, boleh faham tak dia punya solution ni? Okay, so okay, first thing FBD dia, so get it right. So this kind of kalau ada shaft, ada pulley ni kan, you can use the apa ni 2D punya approach, XY plane dan XZ plane. Okay, and then get the combination juga. Okay, moment ke. Okay, so for ini dia punya apa ni, dia punya FBD and the shear moment diagram, bending moment diagram, dan tu can consider macam shear diagram lah. Okay, 900 Newton naik atas. Okay, kemudian horizontal 2700 turun bawah. Okay, so please recall balik. Okay, so what is important, don't forget, get your resultant moment. For example, at point B, Okay, at point B, okay, get the resultant ataupun the total, the net moment. Okay, net moment at point B. Okay, at point B tengok untuk XY plane you will have 225 and for XZ plane you will have 900. Okay, so use that two to get your net moment, so the resultant moment. Okay, MB is equal to 928. And then similar step at point C. Okay, get the total moment MC at point for the first XY plane. Okay, MC is 450. For XZ plane, MC is 450. Okay, so use that value, get your MC value 636. Okay, kemudian apa ni yang bawah ni? C is point B. Okay, so that is the case. Okay, so what is important? The maximum bending moment. Okay, so you compare the two, moment at point B and moment at point C. So you will be able to tell that the maximum bending moment is at pulley B. B is 928 at pulley B. Okay, so that maximum value will be used in the equation. So sigma bending moment is equal to that 32m over pi d cube. Okay, so that is the equation tu. Okay, md over 2 pi d kuasa 4 tu is so from the mc over I. Okay, so you can just use right away 32m over pi d cube. So substitute your m value and then you get your 147. So this is the the sigma moment, bending moment, 147. Okay, the maximum bending stress. Okay, the maximum torsional shear stress occur between B and C. Okay, the tau, the shear stress due to the torsion. Okay, so use that 16T over pi d cube. 16T. Okay, 16T over pi d cube. T is 180. Okay, 180 tu macam mana dapat? How can you get your 180? Afiq.
Yeah,
Can you, how can you get your the T value?
where is it?
Okay, from the picture ni, how can you get your T value? The big T, the torsion or the top.
Oh, torsion. So, the total of top for both pulley is equal to 0. So, so jadinya kita kena tolak pulley ni 1900 tolak 4500 adalah sama dengan 2000 yang pulley sini. Jadinya dapat ini torsion. So jadinya bila mana full torsion macam tu ada.
Okay, betul lah dia punya idea, you get the idea, the total top top at point B, okay, will be equal at top at point C. Okay, so that T tu will be 4,000, for example, 4,500, okay, minus 900 and times the radius. Okay, so don't forget, okay, so the top is going to be the the tension, okay, 4,500, for example, at pulley B, 4,500 minus 900, okay, times the radius of pulley B. Then you get your 180. That is the value. Okay, so for if you refer to pulley C, so 2250 minus 450, and then A times the radius of pulley C. So you get your 180. So that is the top, okay, for the T value. Okay, to the maximum to calculate your maximum torsional shear stress. So that's why they just mentioned between B and C, between that pulley B and pulley C. So normally, okay, this is the apa ni, the way. Okay, you apa ni, you consider the top is in between the two. Okay, the maximum torsional shear stress occur between B and C, and the shear stress, okay, the tau is equal to 16T divided by pi d cube. So T is the big T is 180. Okay, so 16 times T divided by pi d cube. Okay, the shaft is 0.04. So you get your 14.3 megapascal. Okay, the maximum bending and torsional shear stress occur just to the right of pulley B at point E and F, as shown in figure T24E. Okay, at point E, the maximum tensile stress will be sigma 1, given by, okay, ni dah masuk apa ni, dah masuk shear, apa ni, the maximum bending and torsional shear stress occur just to the right of pulley at point B, okay. Maximum bending and torsional at point E. Okay. Maybe at point E and F as shown in figure. At point E, the maximum tensile stress will be given sigma 1. Ni at point E. Okay, ni dah masuk dia punya stress transformation ni. Maximum tension shear stress, okay. Okay, so sigma and apa ni, sigma 1 is the apa ni, the principal stress to sigma 1. Maximum tensile stress, okay, can be calculated. Okay, so pakai sigma, okay, sigma kita dapat tadi lah, sigma apa, sigma bending moment. Okay, so that equation at point F, the maximum compressive stress will be sigma 2 given by, okay, so this is the approach that you can use lah. Okay, so that is applying yang equation for the Mohr circle. Okay, so that is the technique. Okay, so sigma 1 is the tensile stress, sigma 2 compressive. Okay, dapat, and then the shear, the maximum or the extreme shear stress also at E and F. We're just applying the punya equation, okay, using the stress transformation. Okay, any question? Okay, the important part is that for you to remember to consider your total moment. To don't forget, okay, you have to get your total moment or your net moment, and then use that net moment, okay, to calculate your bending stress. Okay, and then for top, if you have the shaft ni, or pulley ni, okay, so that is the technique ataupun method, okay, to calculate your shear stress, get your T, the top value, the torsion value, okay, and then use the equation, and then that sigma, okay, sigma bending moment is going to be your sigma x, okay, and then you can use the sigma 1 equation from the Mohr circle stress transformation. Okay, you get your sigma 1. Sigma 1 is the principal stress. Remember, principal stress mean the shear is 0. The yes, maximum. Okay, and then for sigma 2 is the maximum compressive stress, and then, okay, the rest. Okay, so that is the equation for stress transformation, the last three. So apa lagi ni? Okay dah, itu untuk that example. Okay, kemudian this is mechanical properties of different metal. Okay, kemudian we have look into ini pun dah tengok kan. Okay, static failure. Okay, we mentioned about the theory, static failure theory. Okay, so we have this static failure theory. Okay, so we are going to focus. Okay, remember we are going to focus on ductile material. Okay, so ductile ni yang apa is going to yield first. Okay, so it's going to be only two actually, ductile material, and is going to be MSS, maximum shear stress and distortion energy theory, DET. Okay, there is no universal theory of failure for general case of material properties. Okay, so this is the theory involved for ductile material and brittle material. Okay, so for calculation purpose, okay, for our class, we are going to focus only on MSS dan DE, distortion energy. Maximum normal stress, we will just going to be apa ni, to go through quickly. Okay, so brittle material, okay, okay, normally, okay, the theory we have maximum normal stress, brittle column more than modified more. Okay, so 3 apa? Okay, so behavior of that, okay, can be divided into this kind of diagram. Okay, so epsilon, okay, the changes, this is the strain actually. Okay, brittle behavior, okay, the changes on that material, okay, greater, equal or greater than 0.05. Okay, the strain, okay, changes in the length, okay, from the original, okay, greater than 0.05 is going to be considered as ductile behavior, having ductile behavior. Less than 0.05, okay, is going to be under brittle. And then, okay, they have the different theory related. Okay, so okay, and then what happened is that, okay, why we consider all this failure theory, because we would like to come out or figure out, okay, the safety factor for our component. Okay, we need to design ataupun we have to come out with what is the safety factor for our component, and that will involve this static failure theory and fatigue failure theory later on. Okay, in general, safety factor is going to be equal to significant strength of the material. Okay, biasanya your SUT ataupun SY value, okay, the yield strength value, and then divide by corresponding significant stress, total loading ataupun stresses on the component either. So it's going to be divided, okay, and then we can get safety factor. Or we can also use these formulas, safety factor equal to design overload over normally expected load. Okay, so design overload your itulah SY value ataupun SUT ataupun SUC for brittle material, and then normally expected load. What are the loads, the common that our component will experience. Okay, so it's going to be put into consideration, and safety factor will be calculated from this. So we have this, the maximum shear stress theory I mentioned before. So it is on this safety factor to N is the safety factor tadi SF kan, safety factor. So safety factor dengan symbol N, we can use, so the maximum shear. So remember this is shear stress theory, so it's going to involve shear stress. So N is equal to SY. SY is the material yield strength divided by 2 tau max. 2 times tau max. Tau. The shear stress. The maximum shear stress theory predict that yielding begin whenever a maximum shear stress in any element equal or exceed the maximum shear stress in a tension stress specimen of the same material when that specimen begin to yield. So that is the equation. Sometimes we'll see apa ni 0.5 lah, 0.5 SY. Tau max is equal to 0.5 SY divided by N. So just opposite lah. So so maximum shear stress theory. Kemudian this is another theory. The distortion energy theory. So for in distortion, they have this equivalent or sigma prime. The distortion energy theory predict that yielding occur when the distortion strain energy per unit volume reach or exceed the distortion strain energy per unit volume for you in simple tension. So you have to use this equation. Sigma prime equal to sigma x square minus sigma xy plus sigma y square plus 3 tau square, 3 tau xy square. Sigma prime is the von Mises stress. The last thing is important. That safety factor equation. It is just safety factor is just your SY divided by your sigma prime. So that is the idea. Kemudian this is for maximum normal stress theory. Remember normal stress theory is for brittle, mostly brittle, and it's going to involve SUT. For ductile tadi is SY. SY, this one for brittle is going to apply SUT for tension, SUC for compressive. So SUT ultimate tensile and SUC ultimate compressive strength. So sorry. Example. We're going to use quick example masuk. Okay, we go to the example sekejap. For lagi example saya bagi ni. Okay, tengok example this one. Ini terkena saya bagi. Okay, soalan this question. Jadi kemaman. Ruang kemaman. Amirul, Muhammad Amirul. Soalan ni okey ke? Dapat ke jawab? Dapat.
Tak dapat ada.
Tak dapat Saya belum discuss kat ada jawapan dia.
Belum ada.
Okay, so tengok, we will go through this question exercise 3. Okay, we have okay a bevel system. Okay, the pulley rotate at 3000 rpm, 300 rpm, supported by two bearing. The shaft is made from 1015 HR rod machine, diameter 30 mm. Given belt tension P1 equal to 2.5 times P2. Okay, so okay, tak apa, nanti saya sharekan jawapan dia. Okay, please try solve 1, 2 and 3. Okay, ini okay, tengok dia punya soalan. Find P1 and P2 by equilibrium. T equal summation of T equal to 0. Tadi itu juga. Okay, so to find the torque, the torsion. Okay, what is the torque acting on the shaft? Okay, the T. Okay, find the reaction at the bearing using sigma M equal to 0, sigma F equal to 0. Draw free body diagram from top and front view. Okay, that is the hint. Masa ni senang sikit lah, dia bagi hint juga. Okay, find the most critical moment along the bar. Find the most critical moment along the bar, and then critical moment along the bar, and then 4, using safety factor n equal to 1.25, determine whether the shaft will support all the loads. Answer should be based on MNST, DET and MSST. Okay, MNST yang maximum normal stress. Okay, that is for brittle. Then DET is distortion, energy theory, and then MSST is the maximum shear stress theory. Okay, so this one will cover example for kita punya static failure theory ni. Okay, so I will akan tengok dia punya solution sekejap. Dah share dekat dia ada group. Saya share ni. Okay, nanti saya forward kan. Aku lambat nak lupa. Okay, so this is the exercise and the cara lah nak jawab dia tu. Okay, so the torque acting on the shaft first, you can just use one of the pulley tu. So just use one of the pulley and calculate for the T value. Okay, so T can just use 270 minus 50. 270 minus 50 times 150. Okay, so dapat dia punya T value, the big T. It's 33 Newton meter. 33 Newton meter. Okay, kemudian critical moment, MAMC. Mana MAMC ni? Kita klik dulu. Mana saya tak share ni. Okay, sini pun. Ni saya tak dapat. Okey, sekejap saya tengokkan. Sorry. Sorry. The problem. Okay, first step. Okay, kena cari dia punya P1 and P2. Okay, you can find P1 and P2 by equation tadi, summation of total T equal to 0. So from that equation you can get P1 is 440, P2 is 176. Okay, and then apa lagi? Okay, once you get that one, okay, nanti saya sharekan dalam group lah. Okay, this is the free body diagram. Okay, from top view. Okay, top view. You can consider top view punya plane. Okay, then solve for reaction ROZ, okay, ROZ dan REZ. Okay, P1, P2 tu dah ada. Okay, ROZ you get negative 225. Okay, so turun ke bawah lah nanti maknanya. Okay, it's going to be opposite direction. Okay, and then apa? Okay. Ustaz Hassan okey tak? Okay, so top view is P1 plus P2 cos 45. Okay, so tengok dia punya equation tu baik-baik. So you have your 616 cos, okay, P1 plus P2 is 616 cos 45 times 550. Okay, so that is the taking moment about point E. Okay, so for ROZ you get negative 225.374. Kemudian okay, get your total summation vertical, horizontal, vertical lah ni apa dia. Okay, your REZ dan ROZ. ROZ dapat, REZ, okay, REZ is 109. Okay, once you get the value, okay, you can draw your bending moment diagram. Okay, bending moment diagram. Get your bending moment diagram. Get your value. MAZ. MAZ is minus 67.6. MAZ. Okay, MAZ minus 67.6. Okay, kemudian MCZ. MCZ. Okay. 16.5. Okay, so this is from apa tadi? This is Z punya ni kan, X dengan Z, XZ direction, XZ plane. Okay, so dapat MA Z dan MCZ. Okay, so that is from the top view, XZ plane. Okay, kemudian the second one is the FVD for front view. Okay, front view X dengan Y, XY plane. Okay, XY plane. Okay, XY plane. So sama juga, the same step. Make sure you don't forget. Okay, you have your ROX now, ROX. And then, okay, at point O, kemudian at point A, you have your P1 plus P2 sine 45. Okay, no problem. Okay, sine cos 45, even though the same value kan. Okay, and then you have your REX, okay, at point E. Okay, get your ROX dan REX. Okay, once you get your ROX and REX, solve for moment. Okay, bending moment tu. We need to find MAX and MCX. Fahmi okey tak MAX? MAX dengan MCX.
Okey doktor.
Bagus. Okay, so the same step, balik MAX, MCX. Once you get that, okay, MAX, MCX. Okay, MAX and MCX, that is fine. Okay, ni yang before we get into yang tadi. Okay, so remember, once you get your value to get the total. Okay, the total moment. Okay, for the total moment. Okay, so kena dapatkan lah. MAX apa for point A, MAZ square plus MAX square root. Okay, you get your 108.3 Newton meter. Okay, moment at point A is 108.3. Kemudian moment at point C, okay, so dapatkan dia punya total tu. Okay, at point C is MCZ square plus MCX square root. So you get your 28.3. So you have the two value bending moment at point A and point C. So comparing the two values, okay, you will get your critical. Critical moment is at point A, 108.3. Okay. Then barulah kita pergi masuk tadi tu. Okay, ada soalan ke? Boleh ke? Saya pun tak tahu lah. Dapat betul ke tak. Afiq Abdul kita. Si Afiq je kita tanya. Alif Haikal, ada ke Alif tadi?
Saya dengan faham tadi. Apa dia kata?
Okey, boleh faham.
Saya tengah cuba nak faham.
Okey, kita tengok. Okey. So tadi kita cari moment, we are calculating the moment at point A and at point C. Okay, and then kita dapatkan total moment tu. Okay, once you get the total moment, we compare between the two, okay, to find which one is having the maximum. Okay, the maximum value will be considered as the critical point lah. Okay, so this is the soalan nombor 3 lah. Find the critical moment, a long bar. Okay, the bending moment. Bending moment ni kira stress lah, maknanya bending stress. Okay, bending stress is at point A. Okay, 108.3. Okay. Alif Haikal, okay ke? Adakah Alif? Kemudian baru kita masuk ke sini lah. Okay. So once we get MA dengan MC tadi, so we find that MA is higher. So maximum bending stresses are located at point A. Okay, the torque acting on the shaft 33 Newton meter. Okay, kemudian okay, ni masuk the teori apa static failure theory itu. Okay. So from the okay, from the book, nanti from the table appendix C berapa ni, appendix C berapa? Okay, you need to find your material SUT and SUT and 1015. Apa dia bagi SUT? Sorry. SUT is apa? 340. SUT for 1015. 1015. SAE 1015. HR. Okay, nanti dia tunjukkan mana SUT. Allah. Sorry. SAE 1015, SAE 1015. SAE 1015. 1015. Ultimate strength. Bagi tak boleh, tak boleh. 1015. Sorry, price. Saya carikan SAE 1015. Okay, something. SUT 240. 1015 inshallah. Or okay, yang penting kamu cari SUT value. Mana tadi buku ni? Okay, SUT value. Okay, untuk this is for shear strength. Okay, SUT value. Remember SUT value. Kemudian SY value. SY value is the yield strength. SY value. Yield strength is given 190 megapascal. mana dia punya. Okay, yang penting kamu dapatkan lah maknanya nanti dia punya apa, SUT value, SY value. Okay, kemudian given for example 1.25 safety factor tu. Okay, safety factor. Pecah lah ni. Okay, itu untuk apa tadi ni? Manifest pada maximum bearing. Okay. Kemudian we will start to find the punya bending stresses. Okay, bending stresses. Okay, bending stresses. Diameter of the shaft given 30 mm. 30 mm. Okay, kemudian okay, height of the critical element from central axis. Okay, ini boleh pakai lah. Okay, bending stress. Bending stress. Okay. Okay, yang apa ni my over I ataupun 32M tadi tu kan, 32M over pi d cube tu. Okay, so ini okay, yang penting ialah you use the M value yang use the maximum. Kan yang berapa tadi? 108. Yeah, we are 108.3. Okay, the rest follow. Okay, D is 30 mm tadi. So just solve your sigma bending. Okay, dapat sigma bending 40.857. And then okay, there is no axial load tak ada. And then the next one is on torsion stress. Okay, torsion stress kena pakai tau is TR over J tu. Ataupun yang tadi apa 16T kan, 16T over pi d kuasa 3. Okay. So T is 33. Okay, lain masuk je dalam formula tu 16. Ini dia buat apa, pi d kuasa 4, 32, potong-potong tu lah nanti. Okay, itu yang dapat 64 tu. Okay, tengoklah nanti kan. Okay, and then you will get your tau. Tau will be equal to 6.225. Okay, sigma bending will be considered as your sigma x. Sigma x. Okay, stress along the x. Okay, so sigma x is 40.857. Tau xy is 6.225. Okay, ni dah masuk lah. Okay, kemudian we have to find the principal stress. Okay, principal stress. Okay, the maximum tensile lah kiranya. Okay, sigma 1. So sigma 1 is equal to sigma x divided by 2 plus square root of sigma x over 2 square plus tau square. So just substitute tau x, the sigma x value and tau xy value. You get sigma 1 equal to 41.784. Okay, in terms of the element, stress element, the square tu, okay, you can draw sigma x to the right, tau xy, okay, tau xy to apa ni, the direction pointing downward. Okay, kena clockwise positive. Okay, so pointing downward. Okay, and then sigma y is 0. Okay, the rest follow. Okay, so sigma 2 equation dia uses equation sigma 2 equal to sigma x divided by 2 minus. Okay, so this is the minus. Then you get sigma 2 is negative 0.927 megapascal. Okay, so that is okay, your sigma 1 dan sigma 2. Okay, so calculating principal stresses at critical point. Okay, and then calculate, once you get sigma 1, sigma 2, calculate the maximum torsional stress. Okay, tau max is equal to tau x over 2 square plus tau xy square. So you get your tau max. Tau max is 21.356. Okay. Kemudian tadi dia bagi katakan SUT is 340. Okay, 340. Okay, using for maximum normal shear stress, this is MNST. Okay, for normal stress, okay, this is, we are going to use SUT. Okay, safety factor equal to SUT over sigma 1. Sigma 1 tadi dah dapat value dia. Okay, SUT 340 tu divide by sigma 1, you get 8.137. Okay. Kemudian safety factor for yang untuk apa ni, untuk kompresifnya SUC pula divide by 2 by apa sigma 2, you get 366. Okay, so okay, what is important, you just need to compare. Okay, if our safety factor is greater than the given safety factor, okay, so given safety factor for the problem is 1.25. Okay, if our safety factor now, the calculated, is greater than the given value, then the structure ataupun the component is good. Okay, the shaft is safe. Okay, because we have higher safety factor. Okay, so that is for apa? For normal stress MNST tu, you need to apply SUT. Okay, for DET, we have to apply SY. Okay, if SY value is 190 megapascal, okay, SY, the yield strength 190, okay, we have to calculate the sigma prime first. Okay, the equivalent of von Mises stress. Okay, we have sigma 1, sigma 2, dah ada dah value dia. Okay, sigma 1, sigma 2, you can apply sigma 1, sigma 2 tu. Okay, get sigma prime. So sigma prime is equal to sigma 1 square plus sigma 2 square minus sigma 1, sigma 2. Okay, get sigma prime is 42.255. Safety factor of the shaft, calculate. Okay, SY 190 divided by 42 tu, you get 4.4. So compare with 1.25, your shaft is still good, still more than 1.25. Okay, so that is the approach, okay, that you need to use untuk, okay, for the problem. Lokman, Ahmad Lokman okey ke? Ada ke Ahmad Lokman? Kamil Swaran, okey tak?
Okey, doktor.
Muhammad Anas,
Okay, doktor. So far so good.
okay, I will share. Okay, saya dah share satu soalan tadi dekat group. Okay, so please try that question. Okay, soalan nombor 1. That's 1. So that is the first question. Dan wah, tak boleh tak? Okay. So you are given a structure consists of two member, cantilever OB-AB and a square column CD, which is mounted on the rigid floor as depicted in figure Q1. Overall length of rod AB and CD given 100 mm dan 105 mm. The material IC 1045 HR dan IC 1018A. The design requirement for safety factor is 1.5. All the static failure prevention calculation must be based on the criterion of distortion energy. Okay. Berapa minit lagi tinggal? 4 ke buat? Sekarang. 15 minutes. Okay. Kita tengok soalan ni. Ada nak tanya tak soalan dulu? Alif Haikal? Tengok soalan, okey tak? Draw the free body diagram of rod AB and column CD. Okay. Boleh tak you try sekarang? Draw the free body diagram of rod AB. Rod AB lalu. Try. Rod AB. Okay, please try to draw rod AB punya FBD. So maknanya dekat support B tu nak tengok apa benda. Apa benda
Moment. Bending moment.
Bending moment apa lagi? What do you have? Bending moment satu lagi.
Reaction of force 6 kilonewton downward and at exact axis reaction.
Okay. Okay. So tengok betul-betul. Okay, so from 6 kilonewton vertical tu, okay, so you have counters yang vertical downward. So you akan ada reaction satu, katakan RBY. Okay, RBY will be pointing upward. Okay, counter 6 kilonewton downward tu. And then 6 kilonewton axial tu, you will have to counter for that. Okay, you can label for example RBZ. Okay, in the Z direction to counter for 6 kilonewton along the Z axis. Okay, and then moment. Okay, you will have your moment MBX. Okay, along X direction. Okay, yang 6 kilonewton vertical tu you're going to create. Okay, you're going to create moment 6 kilonewton kali dengan dia punya length. Okay, so you counter for that, you will have your MBX. So ada 3. Okay, ada 3 apa ni? Loading. Okay, dekat support B. Okay, you should have your RBY, RBZ dan MBX. Okay, X pointing ataupun the negative X direction. Okay, so that is for to clear. Nanti saya tunjukkan sikit dia punya solution. Okay, sabar. Kamu ni cepat dapat tangkap. Bagus. Okay, so this is the answer untuk yang pertama tu. Okay, so should be okay to draw. Boleh draw lah betul-betul. Maknanya AY tu ada kan, AY dan AZ. Okay, so that is the FBD free body diagram for rod AB. Okay, rod AB. Kemudian rod CD. Apa column CD? Column CD tu this is the okay, untuk column CD tu you can draw this this way ataupun if you want you can remove AB tu. Okay, and draw the column CD. but that is the okay. Untuk column CD, okay, you will have okay, you have vertical ataupun axial, okay, axial FDY, okay, FDY tu is to counter for FCY dan juga AY. So that's why, okay, FDY will be apa ni? FDY is equal to FCY plus FAY sebenarnya, FAY. Okay. So that is for axial ataupun vertical punya load tu. Kemudian okay, and then you have your RDZ. Saya klik boleh. Sorry, not sorry. Not saya. Saya tekan snap. Okay, so tengok untuk okay, RDZ is to counter your AZ, kemudian MDX1 dan MDX2. Okay, you will have two okay, moment. Due MDX1, okay, MDX1 is due to FAY dan MDX2 for example will be due to FAZ. So ada dua and both in the same direction. And it's going to pergi masuk ke negative X direction. Okay, so please tengok okay tak, boleh faham tak? Okay, so FAY akan kali dengan 125. 125 is the length of AB plus BC. Okay. Kemudian we have FAZ for MDX2. MDX2 is equal to FAZ kali dengan 80. Okay, 80 is from point D naik ke atas point B lah. Okay, so okay, please tengok, give it a try, boleh faham tak? Any problem, let me know. Okay, kemudian we will okay, please try soalan nombor 1 tu lah. Okay, okay, that is apa tu I. Kemudian nombor 2, determine the safety factor. Itu yang answer untuk nombor 1. Okay, number 2 is what? Okay, determine the safety factor of the structure. Which member is the most critical? Will the structure safe under this loading condition? Okay, now once you identify the forces and moment, now we have to calculate what is the forces and moment at that point. Okay, tengok which one is critical. Kemudian you are going to calculate. Okay, find what is the safety factor of that structure. Kemudian compare lah dengan ini given ni berapa ni bagi. Tak bagi. So safety determine berapa safety factor dia. Okay. So okay, kemudian I have mentioned okay, there are exercises in the e-learning. In the e-learning, there are exercises for you to try. Okay, please give it a try. Dan okay, for the answer nanti you back dekat dekat dia punya jawapan tu, nanti they'll give you the answer. Okay, so please give it a try. Bila saya tak check lagi siapa yang dah try. Saya tak ada, dia ada section tu baru seorang ni try. Okay, so anyway, try this question. And okay, I need you to stand by hari apa ni? Selasa. Hari Isnin Selasa. Okay. And we'll discuss on Selasa nanti. Okay, so thank you very much for joining. And any question before we stop? Kamarul Zafran, okay ke Kamarul Zafran? Kamarul, dengar tak? Mana Kamarul? Tadi lama masuk ada. Haris, ada tak Haris? Ikram, mana semua dah hilang?
Ada doktor ada.
Haris, okey ke? Apa yang tak faham? Boleh faham ke masih lagi belum lagi? Belum dapat lagi. Okay, make sure try tengok boleh faham tak? Okay, kalau sangkut, please dapatkan bantuan. Boleh Haris? Fairul ada Fairul? Fairul Izwan?
Ada doktor.
Fairul okey tak?
Okey.
Aminuddin? Ada tak Aminuddin? Okay, so saya akan go through macam ni lah, macam soalan-soalan dia, dan hopefully tengok what are the the technique to be used, to be applied, okay, to answer the question. Okay, so the key point is for you to draw FBD dia betul. Kemudian identify daripada FBD tu kita tahu forces dan moment dan loading dia. And then we are going to calculate maximum dan critical, locate critical point dia. The maximum loading tu nanti will become the critical location, and then the maximum value tu will be used, okay, to calculate the safety factor. Okay, so safety factor normally around 1 to 4, 1.5 to 5 lah. Okay, so you have to get the safety factor value. Kemudian to tengoklah kalau dia give you the safety factor value, you have to double check. Okay, in this question, the requirement for safety factor is 1.5. Okay, so based on 1.5 tu nanti we compare. If you get the safety factor less than that, that means the material ataupun your component is not going to be safe. So that is the idea. Okay, this is using static. After this, masuk fatigue. Fatigue is the repetition of the loading. They keep repeating, giving the stress. Okay, and then tengok what is the endurance limit. Okay, so Okay, give it a try. Try soalan okay. Soalan 1, 2 dan 3. Apa tu? Soalan 1 dengan 2 dulu lah. Okay. And on apa ni? Tuesday. Okay. We will ask you to submit. Okay, please answer and on Tuesday submit number 1 and number 2. And number 3 lah, try sekali lah, tengok nanti kita discuss. Okay, so thank you very much for joining. Sorry for any inconvenience. Anything, please let me know. I will try to assist you. Okay, so terima kasih dan tak habis kan? 10 kan? 11 pula nanti. Okay, so boleh dismiss and saya lupa nak QR scan code attendant nanti. Jadi saya akan share QR scan attendant ni. Okay, so terima kasih. Jumpa lagi. Assalamualaikum.
Thank you, Dr.